Hey, what's up? It's your old pal, Mr. Cook, and we're working through the quiz review, going from 6.5 to 6.8. So we've already gone through some of these problems with condensing and expanding and solving exponents. Now we're going to move on to solving the logarithms. And believe it or not, these are pretty easy to work through. They look really complicated because of all the logs, but if you just use the properties that we practice up here, numbers 1 through 4, and actually not the expanding ones, the condensing ones on 5 through 8, it makes it a lot easier. Because, that's how we make those problems, like number 13 through 20, difficult. We just, kind of make it so that you need to combine them first before, converting into an exponent. And that's what we're going to do each time. We're going to get logs that are either equal to other logarithms or equal to exponents. And if you watched the video on the previous quiz review, you'll see that we had two methods for solving those, and we're actually going to use the exact same methods to solve. If we have a log equal to another log, we just set the parts that are in parentheses equal to each other. So whatever they are, they're just equal. If we have a log equal to a number, then we just convert it to an exponent. And we'll be able to solve it, so we'll use this property over here. Okay, so let's get started on a couple of these. In each case, you need to combine the logs together, so I'm going to actually do that first. So I see that I have two logs that are adding, so that adding turns into multiplying under a single log, so that's what I'm going to use here, log base 8 of, and then I multiply both of these together, so I've got 5 times 2x minus 6. And that's equal to the log base 8 of 75. So that's what I want you to do for all of these first, just combine the logs together, because that's what I'm going to do for the next couple problems. So let's practice that real quick. So I combine these two logs together to make a single log. I'm going to do the same thing here, combining these two logs together to make a single log. So I've got log of, and then it's going to be log of 5 minus log of x, and remember that subtraction turns into division. So this turns into the log of 5 over x, and that's equal to the log of 34. And then for number 15, combining these two logs together, so I've got two logs that are adding. So whenever we add logs together, that turns into multiplication. So we've got log base 2 of 5 times x, and that's equal to 4. And then let's combine these two logs together. So I've got log base 8 of, and then it's two logs and they're subtracting. And remember that subtraction turns into division. So this turns into x in the top, and in the bottom it's going to be x plus 3. And that's equal to the log base 8 of 76. All right, so I'm just going to go through these ones for now, and then when we get to the back, I'll do the same thing of combining the logs together. But this is good enough for what we need to do for right now, because it shows us the two different ways that we're going to solve these equations. One way is when we have two logs that are equal, like in number 13 and also number 14, two logs that are equal. And then we also have another situation where we have a log equal to a number, like number 15. It looks like only number 15 has that right now. So 13, 14, and 16 are all going to be very similar because they all have logs equal to each other. And what you do for that case is you just set the part that's in the parentheses equal. So this becomes 5 times 2x minus 6 equals 75. And then it becomes pretty easy to solve for x. Same thing over here, you just set them equal. 5 over x equals 34. Same thing here. X over x plus 3 is equal to 76. So I'm going to solve all these real quick. Distribute the 5 in there, and you get 10x minus 30 equals 75. Adding 30 to both sides, I get 10x is equal to 105. And then divide by 10, I get x is equal to 10.5. So there's my answer for x there. And then let's see, for this one, I need to multiply both sides by x, so I get 5 is equal to 34x. And then divide both sides by 34, and you get your answer. X is equal to 5 over 34. And then this one is kind of a little tricky because I have two x's, one in the numerator, one in the denominator. So the easiest way to solve it is to turn it into a proportion. So just do 76 over 1, and then cross multiply. So I have x times 1, which is 1x, is equal to 76 times x plus 3. It's important that you distribute that 76 in there. So we have x is equal to 76x plus, and then 3 times 76 is, let's see, 210 plus 18, so 228. And then let's get the XL by itself. So if I subtract 76x from both sides, I get negative 75x is equal to 228. And then if I divide both sides by negative 75, I get x is equal to 228 over negative 75. And that's just, some decimal answer. You can probably reduce this a little bit more because I think both of these are divisible by 3, but I'm just going to leave it like that. Hope you don't mind. All right, so there's my answer for x. One thing that you want to make sure that you do is check for extraneous solutions. So here's the deal. Any log that you have, overall, a number inside the parentheses cannot be negative and it can't be 0. It can only be positive. So even though we get these solutions, what you're going to want to do is plug those values back in as x and see if you get overall a negative number. If you don't, then you're okay. If you don't get 0, you're okay. Just as long as it's positive, you're good to go. So like here's what you would do to check extraneous solutions. Plug in 10.5 for x here and make sure that this overall is a positive number. So 2 times 10.5 minus 6 is 15. So since it's positive, it's good to go. So this one checks out. Let's try that 5 over 34. I just plug it in for x, and it already is a positive number, so if it's going to be the x value, it's going to be positive also, so that one works. This one's negative, so if I plug it in for x, I'm going to get a negative number over here. So I can't take the log of a negative, I can only take the log of a positive. So that means that this answer is actually going to be extraneous, and that means that we actually have no solutions for our answer because it doesn't work out. Isn't that kind of weird? You got to make sure that you check that stuff at the very end. Okay, so we've done the case where it's a log equals to a log. We just set the numbers in parentheses equal. So now let's try when it's a log equal to a number. So when it's a log equal to a number, all you need to do is just turn it into an exponent, and it solves itself pretty much. So turning it into an exponent, I get 2 to the power of 4 is equal to 5x. 2 to the power of 4 is 16. And if 16 is equal to 5x, and if I divide both sides by 5, I get x is equal to 16 over 5. And then if I plug that number, which is positive, in for x over here, it's log of a positive number, so this one checks out. So it's no extraneous solutions here. All right, so that's numbers 13 through 16. Let's move on to the back side and do a couple of those problems as well. 17, 18, 19, and 20. Oh boy, it looks like we got some quadratics, but those aren't terrible because we know how to factor and all of that stuff, so let's work through it. So I'm going to combine these. I'm going to take a couple of steps, at liberty here, just because I don't want to slow down the process. It's because we did all the heavy lifting on the previous problem just to make sure that we know how to do it, so I'm going to do the same thing here, just a little bit faster. So these two logs combine, subtraction turns into division, so this is log base 3 of x squared over 5, and that's equal to log base 3 of 5. Since the logs are the same, I can set the parts in parentheses equal to each other, so x squared over 5 is equal to 5. Multiply both sides by 5, and I get x squared is equal to 25. Take the square root of both sides, and you get x is equal to plus or minus 5, so 5 and negative 5. Now, if I were to plug either of these numbers into x squared, 5 squared is 25, so that's positive, so that one checks out. And then if I plug in negative 5 squared is also positive, so that one checks out. So both of these are good solutions. With natural logs, I just combine them together, so it's going to be ln of, then it's going to be x minus 10, so that means that it's going to be x divided by 10, and that's equal to 2. Remember that whenever you have ln, that's the same as saying log with a base of e. So that means that this turns into e to the second power is equal to x over 10. And then to get x by itself, I just simply multiply both sides by 10, and I get x is equal to 10 times e squared. And that's just going to be some number that you can use. It's positive, so when you plug it into here, it'll work out okay. So that one checks out. It's not extraneous. Now number 19. So for number 19, we're going to combine the logs together. So I get log base 7 of x minus 2 times x minus 4. And then that's equal to log base 7 of 48. So since I have two logs that are equal, I can set these two parts equal. So I get x minus 2 times x minus 4 equals 48. And then if I FOIL or distribute this out, I get x squared minus 6x plus 8 is equal to 48. And then whenever you have a quadratic, make sure to zero out one side. So I'm going to subtract 48 from both sides and get x squared minus 6x, and then 48 subtracted from 8 is going to give you negative 40. And then are there two numbers that multiply together to be negative 40 and add together to be negative 6? Yep, there are. It's negative 10 and positive 4. So this becomes x minus 10, x plus 4 equals 0. And that gives me two solutions. One, x is equal to 10, and number two, x is equal to negative 4. So let's see if both of those work out. Let me plug them back in. If I plug in 10, 10 minus 2 is 8, so that's good. And then 10 minus 4 is 6, so that's also good. But if I plug in negative 4 minus 2 is negative 6. Can I take the log of a negative? No. So that means that this one does not work, but this one does work. So 10 is going to be my answer for that one. And then one last one before I start up the word problems. So I've got log base 3. And then it's going to be this minus this log. So it's going to turn into division because of that minus there. So this becomes 3x to the second power minus 9 over 6. And then that's equal to 1. So when I have a log equal to a number, I turn it into an exponent. So it's going to be 3 to the first power is equal to 3x squared minus 9 over 6. And then I can just multiply both sides by 6. So I get 18 is equal to 3x squared minus 9. Add 9 to both sides, you get 27 is equal to 3x squared. Divide both sides by 3, and you get 9 is equal to x squared. And then take the square root of both sides, and you get x is equal to 3 and also negative 3. So those are my two solutions. Now if I plug them in, 3 plugged in here, 3 squared is 9. 9 times 3 is 27. 27 minus 9 is a positive number. So that one works. And then negative 3 squared is 9. 9 times 3 is 27. 27 minus 9 is 18, so that's positive as well. So both of these work out just fine. Okay, so that's the first 20 problems, and then my next video is going to focus on the word problems. So make sure that you have those formulas out if you need to remember like the variables and all that stuff. Okay, that's it for this video. On to the next one.